Alright, so we're going to consider the following game with two players. Player 1 chooses top, middle, or bottom, so we'll denote those by T and B. And player 2 can choose among actions L, C, and R. So just for clarity, the payoffs on the left refer to player 1. Payoffs on the right refer to player 2. So just like we've done, we have player 1 on the left, player 2 on the top or the right. So what we first want to do is identify if player 1 has a dominant strategy. So dominant means better than all of my other actions. So if I have a dominant strategy, it means that there's a strategy which I always want to play. So we have to go through and see if there are any of these. So the way we can do this is just by looking at player 1's best responses to any of the actions taken by player 2. So first we say, what happens if player 2 plays L? And we're in this column. Let's look at the payoffs for player 1. Player 1 gets 2 if they play T, 3 if they play M, and 1 if they play B. So here their best response is to play M. When player 2 plays action C, we're in this column, and we want to compare the payoffs to player 1. They get 1 if they play T, 1 if they play M, and 0 if they play B. We can see that their best response, or the best responses, is to play T or M. Finally, we look at what happens when player 2 plays R. And we're in this column. We look at the payoffs for player 1. We see that they get the highest payoff of 4 when they play T. So our question is, does player 1 have a dominant strategy? Well, was there any action that was always better for player 1? No, because, well, let's look. When player 2 plays L, it's best for player 1 to play M. This is their best response. However, when player 2 plays R, it's best for them to play T. Neither of these are always the best response, given any action of the other player, which means that there is no dominant strategy for player 1. So for A, the first question is no. The first answer is no. We now want to look at whether player 2 has a dominant strategy. So we do the same thing. We go through and look at player 2's payoffs given a fixed action of player 1. So suppose player 1's playing T. What's the best response of player 2? Well, the best response is to play R, because they get payoff of 0 if they play L, 1 if they play C, and 2 if they play R. So they prefer to play R. Now, given that player 1 is playing M, the best response of player 2 is to play L, because they're looking between 4, 2, and 3. So they prefer to play L and get 4. Finally, when player 1 plays B, they are comparing actions of 3, 2, and 0. So we see that we see that they want to play L so that they get a payoff of 3. Now here, again, we can look and go through the actions of player 2 and see if any of them are always the best response. We see that L is a best response when player 1 plays M or B, but it's not a best response when they play T, because we see that the best response would be to play R. Similarly, when player 2, let's look at C. When player 2 plays C, well, this is the best response when player 1 plays T or M, but it's not a best response when player 1 plays B, because player 2's best response is to play L. So 2 is not a dominant strategy. Now let's look at R. Here we see that R is a best response when player 1 plays T, but it's not a best response when player 1 plays M. So none of these are dominant. So both of those are no. Okay, so we went through and found best responses. It's now going to be easy for us to find the pure strategy Nash Equilibria. So all we have to do is look for cells which have 2 underlines. So here we can look through all the cells in this table and we see that this one has 2 underlines. Yeah. And so does this one. Oh no. Okay. That was not what I wanted. Okay. So both of these are Nash equilibria. So let's kind of walk through why. So I'm just going to write PSNE. So this stands for pure strategy Nash equilibria. The PS is pure strategy, NE is Nash equilibrium. So this is going to be ML, because this corresponds to this configuration, and TR. Okay, so why? Well, what we want to do is we want to find mutual best responses. So when player 1 plays M and player 2 plays L, we see that both of these actions is the best response to the other player. Sorry for zooming out there. So when player 2 plays L, it's the best response for player 1 to continue playing M. So this kind of is stable. Given that player 2 plays L, it's the best response for player 1 to continue playing M. Similarly, when player 1 is playing M, player 2 has no incentive to deviate. They've no better option. This is their best response. So this is a stable point for both players. So this is a Nash equilibrium. Similarly, what we can do is we can say, okay, look at TR. Player 2 has no incentive to change from here because they get payoff 2 here, and they get payoff 0 here and 1 here. They have no reason to switch. This is their best response, given that player 1 is playing this equilibrium strategy. Similarly, if player 2 is playing R in equilibrium, the best response of player 1 is to continue playing T. They have no incentive to change. So these are the 2 Nash equilibria of this game in pure strategies.